This section of our geometry unit is probably something you've done before. So geometry, we're going to talk about perimeter a little bit, but mostly about area and volume of different shapes. So the perimeter is really the distance around a shape. And so you could have the perimeter of a square, right? It would be 4 times the length of the sides. You could have the perimeter of a rectangle, would be twice the length plus twice the width. You could have the perimeter of a triangle, the sum of the 3 sides. You could have the perimeter of a circle, which is in our notes here, the circumference of a circle. It's really just adding together the linear measurements. And so they would be measured in centimeters or kilometers or that kind of thing. Area is measured in squared units. It's the amount of surface area enclosed by the shape or the figure. So if you had a shape, you could count how many square centimeters fit in it, and that's what we're trying to do here. Or you could calculate it. So if we count it, we get up to 12, and then we have 1.5 of those half-size rectangles for a total of 13.5 centimeters. We could also calculate this. The area would equal the length times the width. You've probably done this before. So the length here would be 1, 2, 3, 4.5. And the width would be times 3. So 4.5 times 3, you can do that on your calculator, is 13.5. It always comes out into squared units, so this would be measured in centimeters squared. And so all area is in squared unit, or squared units, sorry. I put an S on the end of area there, sorry. So area is in squared units, and really depends what your lengths are measured in, what your area is going to come out in. Obviously, counting isn't the way to go. You do have in your formula sheets a lot of different formulas. You probably remember this one, and we've already just used it, that area is length times width when we're dealing with a rectangle. Technically, you could do the area of a square also as length times width, but the special thing about squares is the sides are equal in length. And so we'd seen that before with the lines drawn on things, right? They're equal in length, so you really could just multiply the 2 together or squared that one length of the side. So these are formulas that are in your formula pages. You do not need to have them memorized, but you do need to know how to use them. So our first example here is probably one you've done, and I made it so that you realized you have to have the same units. So we'd have to put this into centimeters, so that would be 12.6 centimeters, right? And so then that allows me to use the area is equal to the length times the width, or area is equal to 12.6 times the 6.4. I make sure my units are correct first, and then I do the math on my calculator. Make sure to include those units. This is 80.64 centimeters squared. And obviously impractical to count, and you don't have the information to count them. So obviously we're going to be doing the calculation. Don't forget the units. Okay, so really squares and rectangles are 4-sided figures, so they're technically quadrilaterals. The other options that we have for quadrilaterals will be parallelograms or trapezoids. And so parallelograms are here. And even though they look tricky, they're really just the same as calculating the length, or sorry, the area of a rectangle. Basically, if we take this triangle off the end and squish it onto this end, what you make is a square. And so if we calculate base times height for a parallelogram, that's how we're going to calculate the area. So nothing too scary there with the parallelogram. The trapezoid is a little bit different, and again, you do not need to memorize these. So a trapezoid has a different sort of shape, where instead of the parallelogram having all the sides parallel, you have this tapering in of the trapezoid. So the trapezoid formula is 1/2 times the height, and this would be the height right here, times the upper base plus the lower base. So let's take a look at this. We have an example down here, and it looks a little funny. Hopefully it looks neater in your notes. In this one, area equaling 1/2 the height times the top base plus the bottom base. Let's sub in so we can put this into our calculator. So 1/2 times 25, you can always put 0.5 in your calculator, times, put the brackets around this because you have to add those. Remember, order of operation matters. We've got 4.3 and 6 in there. So I did this on my calculator, remembering to do that part first, right? You can write down the steps, or if you put it into your calculator properly, you can do it in one fell swoop. What you should end up with this one is 12.875 centimeters squared, remembering the units each and every time. The units going in are in centimeters, so the units coming out are in centimeters squared because we're calculating the area. So we've done squares, we've done rectangles, we've done parallelograms and trapezoids. Let's take a look at some practice on these. If you want, you could pause the video and give them some practice. I'm going to speed it up because I feel like this is something that people have done before. I'll write down the equation that we're using for the formula for each, and then I'm just going to go ahead and write the answer in. The answer key has all the steps shown. I tend to use uppercase letters, and I think your formula sheets have the lowercase sometimes. In this one we have a red herring. If you had to calculate the perimeter, you could. And again, I'm just writing out the formulas and the answers. You could show all your work. But I think those are the key pieces of information for you making the sense of it. All right, so we got lots of four-sided things here. Let's move on to the three-sided things. So three-sided things are triangles, as we know. And the triangle formula for us is area is equal to 1/2 the base, which is here, right, times the height. And the height is from the base up to the top of the triangle. Sometimes these things are shifted around. The notes explain that the area is really half of the area of a parallelogram. You don't have to derive these, you need to know how to use them and find them in your formula pages. So that's the equation. It's written at the top of the next page so we can practice using this. So these ones, the area is going to equal 1/2 the base times the height. In this case, the base is 8 centimeters. And the height, even though it's flipped all around, is going to be 3 centimeters. So the area is going to come out in squared centimeters. I can do this on my calculator. I tend to put in 0.5 when I see a half, or you could take your answer and divide it by 2. That does the same thing. You can try it either way. So the area for this guy is 12 centimeters squared. Remember, don't slip on the units. The next one, again, area would be 1/2 of 4 times 3. You can do this either which way. You can put in 0.5 times 4 times 3, or you can take 4 times 3 and divide it by 2. You will get the same answer. It works out to 6 centimeters squared for your area. There's more to try. This one does, for only a very few questions, ask you the perimeter of the following triangles. I didn't put that in my key. You could calculate that. Oh, I did put it in my key. Sorry, I was lying. So I'll go ahead and the area equation is always 1/2 the base. And sometimes it takes a little bit to figure out which numbers are going with what concept, times the height. And then the perimeter, again, trying to read this and figure out what the lengths are. A is 4.46 millimeters. B is 9.21. I'm just reading them off here. It's much easier when they're labeled on the shape, but that's okay, we can manage. And C is 9.7. So the perimeter of this works out to 23.37, not millimeters squared, just linear millimeters. I'm going to throw the answers for the last two here. Take your time. This one's an equilateral triangle, so you only needed one of the sides. Area, I didn't show my work on this. You do it and check your work. And perimeter. And then the last one, again, I'll just throw the answers on here. You can give them a try on your own. And this is an isosceles triangle. Oops, I was writing out all my work. I said I was just going to put the answer there. Probably doing this faster than I am. Okay, 18.4 centimeters. Remembering that perimeter is just linear distance and area is units squared. So we've done quadrilaterals, we've done triangles. Up next are circles. And circles involve a constant called pi. Pi is derived from a truth of all circles, and the ratio between the circumference or the perimeter of a circle and the radius or the distance, so the diameter of the circle. So in this one, we have two different equations. And so we have area, pi r squared, and perimeter as pi d. Sometimes you may have learned the perimeter as 2r or pi 2r or 2r pi, right? Because the relationship between radius and diameter is key to understand. Radius is halfway across the circle. So from the center to the edge, that's the radius. Whereas diameter is the whole distance across. And so our radius is always going to be half of our diameter, or our diameter is always going to be double our radius. And so we can think of it that way. These, again, are not needed to be memorized. I always remember this one. This is my memory device. A is for alphabetical. Obviously it's not, it's for area, but this equation is in alphabetical order, P, R, S, and you can't say it any other way. These ones over here, you can kind of have different versions of them, and sometimes they could be in alphabetical order, but anyway, that's just my memory device, and again, you don't have to have them memorized because you have your formula sheets for these. So this example here, we want to find the area and the perimeter, or the circumference of the circle. We have the diameter of 12. And so the area would equal pi r squared. If we know the diameter, then the radius is going to be half of that, is going to be 6 meters. And so I could put that into my calculator. I'd have pi times 6 squared. Now, sometimes when you learn geometry, you learn that pi is 3.14. It is not. You have a button on your calculator that says pi. Sometimes you have to hit a second function button. Pi is a number that goes on forever. So use your calculator when you're going to multiply by pi. In that case, you're going to have to round your answer. Because the pi number goes on forever, you're going to have to round your answer to give an answer. And so I've tried to do that in all the questions. So the area of this, pi times 6 squared, should work out to the nearest whole number to 113 meters squared. If we were to figure out the circumference or the perimeter, so perimeter or circumference, that would be pi times d, or twice the radius. If you're given the radius, you're just going to multiply it by 2. So again, with this one, we want to make sure that we're using pi on our calculator and multiplying it by 12. We're going to round to the nearest whole number, and that works out to, where is it, 38 meters. So two different equations. Using your calculator is key for that pi, and remembering to round. We've got a few examples to do down here. Find the area and the perimeter of these guys. So the area of this first one would be pi r, which is 2 squared. It says rounded 2 decimals for each. If I put that into my calculator, it works out to 12.57 centimeters squared. The perimeter of this would be pi times 2 times r, which is 2, right? You could think of it as pi d. The distance here, d is going to be 4, right? The whole diameter across. So again, using our calculator and rounding to 2 decimal places, I get 12.57 centimeters for my perimeter of that circle. B is a little bit harder. It's a little bit different. Let's figure out the area first. So the area is really going to be half of a whole circle, of an entire circle. So the area is going to be pi r squared. I don't have r, I have d. So radius would equal half of this. So that's 3.4 centimeters. I like kind of doing it on here rather than all in the equation. So I'd have 3.4 squared. And then I only have half a circle, so I'm going to take the whole thing and divide it by 2 on my calculator. You could put it all over 2 or just throw this in your calculator as you go. If I round to 2 decimals, I get an answer of 18.16 centimeters squared for my area. Okay, the perimeter is a little bit trickier. So in this one, we have to figure out, I'm going to switch colors for us, we're going to figure out the perimeter or the circumference of half of the circle. And then we're also going to have to add in this base as it's measured here, right? It's the diameter. And so we'd have to remember to add that piece back in. So coming up with the equation for this, the perimeter would be 1/2 of pi d, because the whole circumference would be pi d, so we only need half of it, and my diameter is 6.8, plus another 6.8, because that is the pink stuff down the bottom. That 6.8 is the base of my circle. So in my calculator, this first part worked out to 10.68 plus the 6.8, I'd round to the 2 decimal places, 17.48 centimeters. Little bit of a challenge one. Okay, so that does us for area and the little bit of perimeter that we're going to do. Now let's move on to volume. So volume measures the amount of three-dimensional space that an object takes up. You can measure volume in liquid, milliliters, and liters. We're going to stay with cubic linear measurements. And so like we did before, you could go about counting these. If you want to use your imagination and count these, it's a bit of a head trip. You could count 36 cubic centimeters in that, or 36 cubic units, if you will, because they're all little cubes, right? You're not going to have to count these. Obviously, we've been calculating areas. We're going to calculate volumes. You could also notice that we have a length, a width, and a height. If you multiply these all together, that's the way of calculating the cubic units. So the units, like I had said, are cubic. You could talk about cubic millimeters, cubic centimeters, cubic meters. They get much larger volumes quickly. And generally what we're doing, the volume is the area around the shape times the height. So that's the bottom part of the notes here. It's really meant to kind of unify the different equations that we're going to go through. But I will remind you, you have formula pages that look an awful lot like this. I've noticed the print quality on these are maybe a little bit poor. So double check that you understand what they say. This one specifically is kind of weak. So double check those and make sure that they're usable and useful and understandable to you. So let's try using these equations. These are probably things you've done before, so somewhat of a review, but kind of on new terms. Now this looks a little scrambled. Hopefully yours looks a little better. This should say 30 centimeters. This should say 12 centimeters. And that should say 2 centimeters. I hope yours didn't get so scrambled. So the area of this is a rectangular prism. Fancy word for a box, really. It's length times width times height. It doesn't really matter which order you put these in as. We've got 30 times 12 times 2. On your calculator, you could calculate this to be 720 centimeters cubed. We've got 3 different centimeter units going in, so the units come out as cubic measurements. The next one, we have a cylinder, if you will. So that's like taking the area of the base and then multiplying it by the height. You don't have to have this memorized. The equation is area is pi r squared times the height. So pi, again on your calculator, we're going to round to 2 decimals it says. The radius is 0.5, don't forget to square it, and the height is 16 meters. Everything's in meters, so my answer is going to come out in cubic meters. This is a big pipe. I get 12.57 meters cubed when I put that in my calculator, and then round to the 2 decimals. All right, we've got some more on the next page. We have a volume of a cone. I did not remember the formula for the volume of a cone. I definitely had to look that one up. So the volume is 1/3 pi r squared times the height. So we're given the diameter. The radius is going to be half of that. That's going to be 20 centimeters. This 80, even though it's going across the page, is technically the height of the cone. So we're going to go ahead and sub in what we've got here, 1/3 pi. Again, I'm not using 3.14, I'm using that button on my calculator. The radius is 20, don't forget to square it, and the height is 80. Now doing this on your calculator, we've had 1/2 in our equations, but we've not had the 1/3. When we had the 1/2, I told you you could just divide by 2 at the end. The same with this. If you'll notice on the formula pages, it's given as an alternate. So on my calculator, what I would do is I'd hit the pi button, I'd multiply it by 20 squared, multiply it by 80, and then divide by 3. You're going to get the same answer as if you multiplied by 1/3. So I think that that's a lot easier on calculators. In this one, when we round to the nearest whole number, I get a whole number of 10,667 centimeters cubed. Take a minute to be familiar with your calculator because I think that's a lot, it's an important skill in this. So what I'm saying is you could just forget that there and take your answer and divide it by 3. You're going to get to the same answer there. And that's something you can do most easily on your calculator. Okay, so the volume of a basketball. Oh my goodness, this is an equation and a half. So the volume equation for this is 4/3 pi r cubed. So in this one, I could take 4, divide it by 3, multiply it by pi, and multiply it by the radius cubed. So 4/3 pi, my radius is 20. Don't forget to cube that one. So in this one, again, a little bit of calculator work. Take your time to punch it in. We're going to round this to the nearest whole number. So we get 33,510 centimeters cubed. Oops, almost forgot that part. Whole point of what we're doing here, cubic volumes, right? Okay, on to the last couple. Oh, sorry, the last 3. Also, not memorizing these formulas. The volume of this is kind of like the pipe. So we'd have the pi r squared times the height. Again, I'm given the diameter, so my radius would be 1.5 feet or half of 3. right? I usually do that outside of this equation because then this gives me something I can put into my calculator. It says round to the nearest whole number. So in this one, I'd get 28 cubic feet, or feet cubed. Last one, or so last two here, I'd have the area of the end shape times the height. So the volume of this triangular prism would be 1/2 the base times the height times the length. And so the volume would be 1/2 times 4 times 3 times 11, right? This is that length of the thing. In my calculator, I'd get 66. Now I don't have any units on this, so I would simply say units cubed. Same for the last one. It's not measured out, or it's not given to me how many units or what the units are in. The volume of this is going to be the length times the width times the height in whatever order you like. These three numbers of this rectangular prism, or you could think of it as a box, I'd have 12 times 8 times 6 in any order you like. And my calculator helped me calculate this is 576 units cubed.